Good morning, students. Today I will start numericals on semiconductor electronics, last chapter, and the question is that the electrical conductivity of a semiconductor increases when electromagnetic radiation of wavelength shorter than 2480 nanometer is incident on it. What is the band gap energy in electron volt for semiconductor? In the given question, we have to find out band gap energy. That means we have to find out Eg. Eg, that is the symbol of band gap energy. Eg, band gap energy. G for gap, E for energy. Band gap energy. This is also called energy gap. In the given question, we have only given that wavelength 2480 nanometer, and we have to find out in electron volt. That means we have to convert this energy gap in electron volt. We know that energy E is equal to h nu. Now Eg is equal to h nu, where Eg is band gap energy, h is Planck constant, and nu is the frequency. Now we can write down, because nu is equal to c by lambda. Nu is the frequency, c is the velocity of light, and lambda is the wavelength. Then Eg is equal to h. Now substitute nu is equal to c by lambda. Then Eg is equal to h, nu is equal to c by lambda. Now substitute the value. H is Planck constant. The value of Planck constant 6.63 into 10 to the power minus 34 joule per second. What is the value of Planck constant? The value of Planck constant H is equal to 6.63 into 10 to the power minus 34 joule per second. That is the value of Planck constant. C is the velocity of light. The value of velocity of light, all of you know that. What? 3 is to 10 to the power 8 meter per second. Now lambda is the wavelength. Wavelength given that 2480 nanometer. All of you know that 1 nanometer is equal to 10 to the power minus 9 meter. That is the value of 1 nanometer. Now we have to convert it in electron volt. All of you know that the value of 1 electron, the charge of 1 electron, 1.6 into 10 to the power minus 19 coulomb. Then 1 electron volt is equal to what? 1.6 into 10 to the power minus 19. This is divided by this. Then this is converted into electron volt. Now substitute all these values. Planck constant 6.6 into 10 to the power minus 34 joule per second. Velocity of light 3 into 10 to the power 8 meter per second. Lambda wavelength 2480 nanometer, and this is divided by 1.6 into 10 to the power minus 19, because we have to convert it in electron volt. Now substitute all these values. Eg is equal to 6.6 into 134, velocity of light 3 into 10 to the power 8, electron volt 1.19, and 2480. Now this 2480 nanometer, then this is converted into meter. 1 nanometer is equal to 10 to the power minus 9 meter. 2480 into 10 to the power minus 9 meter. 6.63 into 3. Now this 10 to the power minus 34 into 10 to the power 8. 10 to the power minus 34 into 10 to the power 8. This will be 10 to the power minus 26. Minus 34 plus 8. 10 to the power minus 26. 6.63 into 3 into 10 to the power minus 26. 6.63 into 3. 10 to the power minus 34, 10 to the power 8, 10 to the power minus 26, divided by 1.6 into 10 to the power minus 19, 2480. Now nanometer is converted into meter. 2480 nanometer, 1 nanometer is equal to 10 to the power minus 9 meter. This will be 10 to the power minus 9 meter. Here 10 to the power minus 19 into 10 to the power minus 9. This will be 10 to the power minus 28. This will be 6.63 into 3. This is multiply 6.6 into 3. That means 19.89. 19.89 into 10 to the power minus 26 divided by 1.6 into 2480. 10 to the power minus 19 into 10 to the power minus 9. This will be 10 to the power minus 28. Then 2480 into 1.6, this is multiply, and after multiply we get 3968. This 10 to power minus 26 divided by 10 to power minus 28, this 10 to power minus 28 upward 10 to power plus 28, 10 to power plus 28 into 10 to power minus 26, that is 10 to power 2, 10 to power 2, that means this will be 100. That means 19.89 multiply 100 divided by 3968. 1989 into 100, this will be 1989 divided by 3968. After this we get 1989, that is divided by 3968, that means E is equal to 0.5012 electron volt. Approximately we can write it, band gap energy E is equal to 0.5 electron volt. According to question, we have to find out what is the band gap energy in electron volt, and the band gap energy in electron volt, that is 0.5 electron volt. This is the main problem of this chapter, and first of all of you practice it and learn all these formula that is related to this chapter, chapter number 14, Semiconductor Electronics, as well as you have to learn all formula of atoms and nuclei. That is previous chapter, we have already discussed it in class. Thank you. The next problem is the threshold voltage of a silicon diode is 0.7 volt. The threshold voltage, that symbol is Vt. Vt is the symbol of threshold voltage. T for threshold, V for voltage. It is operated at this point by connecting the diode in series with the battery of V volt, and the resistor of 1000 ohm. Find the value of V when the current is 15 milliampere. According to question, we have to given that threshold voltage Vt is equal to 0.7 volt. This is the threshold voltage, 0.7 volt. Now we have to find out EMF of the battery. Now the battery of V volt, that means we have to calculate EMF of the battery V volt. We have to solve the value of V. We have to calculate the value of this V. What is the value of this V? So we have the value threshold voltage Vt is equal to 0.7 volt. EMF of the battery V volt we have to calculate. This is question mark. We have to find it. And resistor R is equal to 1000 ohm, and the current I is given that 15 milliampere. This 15 milliampere, that is converted into 15 into 10 to power minus 3 ampere. We know that 1 milliampere is equal to what? 1 milliampere is equal to 10 to power minus 3 ampere. 1 milliampere is equal to what? 10 to power minus 3 ampere. That means we have the value threshold voltage 0.7 volt. We have to find out EMF of the battery V volt. We have to calculate V value. Resistor R 1000 ohm. Current I 15 milliampere. 1 milliampere 10 to power minus 3 ampere. That means 15 milliampere is equal to 15 10 to power minus 3 ampere. All of you know that Ohm's law. Ohm's law, V is equal to what? IR. We have to find out the value of V, and we have value current, voltage and resistor. That means I is equal to what? V upon R. And we have already discussed this formula. I is equal to V minus Vt upon R. I is equal to V minus Vt upon R. The value of I 15 milliampere. Substitute this value 15 into 10 to the power minus 3 ampere. We have to find V. Threshold voltage Vt is given that 0.7 volt. And also resistor R is equal to 1000 ohm. All these the values of current I, threshold voltage and the resistor, these values substitute in this given equation. I is equal to V minus Vt upon R. I is equal to 15 to the power minus 3 ampere. V minus Vt 0.7, R 1000. This 1000 cross multiply 10 to power 3, 10 to power 3 plus in 10 to power minus 3 minus 10 to power 3 and 10 to power minus 3, 10 to power 0. All of you know that 10 to power 0 is equal to 1. That means 15 is to 1, 1. 15 is to 1, 15. 10 to power 3 into 10 to power minus 3, 10 to power 0, or 10 to power 0 is equal to what? 1. 15 is to 1, 15 is to 1, that means 15 volt is equal to V minus 0.7. Then substitute 0.7 here, left side 15 plus 0.7, 15.7 volt. Then the value of EMF of the battery what? V is equal to 15.7 volt. We have to find out the value of this EMF of the battery, and the question is, say that we have to calculate what is the value of V when the current is 15 milliampere. As per question, we have find out the value of EMF of the battery. V is equal to 15.7 volt. Okay? Is that clear? So practice also this question and learn all these formula of this chapter, like as semiconductor electronics. In semiconductor electronics, we have to learn intrinsic semiconductor, extrinsic semiconductor, rectifier, half wave rectifier, full wave rectifier, as well as in half wave rectifier you have to learn efficiency. Efficiency, that means efficiency eta. What is the efficiency of half wave rectifier and full wave rectifier, and which component is used in half wave rectifier as well as full wave rectifier? Because the chapter is semiconductor electronics, that's related to material, devices and simple circuit. So in this chapter we have already studied semiconductor types, semiconductor band gap energy, forbidden energy gap, intrinsic, extrinsic, etc., as well as devices, rectifier, half wave rectifier, full wave rectifier, semiconductor diode. So all of you have to learn all these formula and all these topics related to this chapter. Thank you.